Today we're tackling some networking concepts that can trip people up in practice for the HPE 7-A11 exam.
Yeah, we're doing a deep dive into some seriously practical stuff. Things like navigating physical campus designs, untangling tricky UXI and gateway licensing, and, well, planning upgrade behaviors.
Right, and understanding VXLAN routing. The best way to nail these is to walk through actual exam questions. So let's jump right into some real problems so you can see how these topics get tested.
I'm ready when you are.
First up, when does it actually make sense to choose a two-tier campus LAN design instead of a three-tier architecture? Is it when you expand beyond several aggregation points, when cross-campus traffic exceeds your core capacity, when you just have small buildings with few closets, or when access aggregation can't scale?
Well, if we're hitting capacity limits or rapidly expanding, I'd intuitively argue for the capacity option, upgrading for heavy traffic.
But that's exactly where they get you. If you need high traffic scaling, that absolutely demands a three-tier design to manage the load.
Oh, right. So the answer is just having small buildings with few closets.
Exactly. Think of a small branch office versus a massive university campus. For a small footprint, a two-tier collapsed core is all you need. You can toss out the capacity and scaling options entirely.
Gotcha. So physical scale drives the architecture. But once you build it, how do you know what the user experience is actually like on the floor?
That brings us perfectly to managing endpoints, specifically Zebra devices running UXI. Which two licenses are required here? You've got an LTE subscription, a UXI cloud subscription, wireless insights, or a UXI agent subscription.
I mean, for mobile scanners, LTE and wireless insights sound like incredibly relevant in the real world. I'd lean toward those.
It's a total familiarity trap. The actual requirements are the cloud and agent subscriptions.
Wait, really? Not wireless insights?
Nope. UXI needs software running locally on the scanner to gather data, which is the agent. And to actually read that data, you need the dashboard, which is the cloud.
So wireless insights and LTE sound good, but they don't give you the core UXI mechanics.
Right, you need the sensor in the brain. And managing those local agents naturally leads to how we securely onboard them.
So let's look at secure device enrollment with ClearPass Onboard and PKI integration. We need two recommendations. The options are OpsRamp EST integration, the idea that Onboard cannot proxy requests to an external CA, that multiple PKIs require a Foundation plus security subscription, or using an Onboard CA EST server.
Well, a lot of admins treat ClearPass like an island, so I'd bet they think Onboard cannot proxy requests to an external CA.
That is a classic misconception. It absolutely can proxy those requests. The real recommendations are the auto-renewing EST server and that multiple CAs need the advanced subscription.
So it's like automating employee badge renewals so your help desk isn't manually printing them every single morning.
Exactly. The OpsRamp option is totally unrelated, and that proxy limitation is just a pure trap.
Automating the heavy lifting is crucial. So we secure the endpoints, but let's talk about how UXI actually monitors this traffic.
Good point. What are two accurate statements about UXI sensors? Do they integrate with SSE for data protection, only perform passive monitoring, provide 24/7 cloud monitoring, or does the Linux agent provide features with reduced performance?
Traditional network monitoring is almost always passive, just listening. So passive monitoring feels like a really safe answer.
In traditional tools, yeah. But UXI acts like a secret shopper. It actively generates synthetic traffic around the clock to genuinely test the network.
Oh, wow. So it's not passive at all.
Not at all. The true statements are the 24/7 cloud monitoring and the fact that the Linux agent provides features with reduced performance. Data protection is just way outside UXI's job.
So it's actively probing. Now, what happens to that continuous uptime when you need to upgrade your switches?
This one catches a lot of people. When performing an in-service software upgrade, an ISSU, on a VSF switch stack, which members require a reboot. Just a member, the standby, the conductor, or all member types.
I mean, the name is literally in service. So to keep it in service, I'd say only the standby reboots while the conductor handles traffic.
I hate to break it to you, but it's all member types. It's a huge trap.
Wait, all of them?
Yeah, because VSF virtual switching frameworks share a single control plane. An upgrade requires the whole stack to reboot. You still have to schedule a maintenance window, despite the in-service name.
Ouch. That is a brutal reality check. So physical switches reboot, but how do we handle the virtual fabric spanning them?
Let's look at EVPN-VXLAN. Which two statements describe its characteristics? Does VBNT describe static segmentation? Does MPBGP create GRE over UDP tunnels? Are route distinguishers unique to VTEPs, or is ARP suppression supported via Type 2 NLRI?
Tunneling usually relies on GRE, so I'd probably pick the GRE over UDP option.
Actually, VXLAN encapsulates layer 2 frames directly into UDP, skipping GRE entirely.
Oh, right.
Yeah, the correct traits are the root distinguishers and ARP suppression. Think of it like a secure apartment building. Root distinguishers act like unique zip codes so identical apartment numbers don't get mixed up.
And the ARP suppression keeps the noisy broadcast traffic down, right? So we can eliminate GRE and VBNT.
Exactly. So you've engineered this brilliant, quiet fabric. How do you actually justify the cost to leadership?
When presenting this network design to a customer, what is the most important thing to include? Your personal experience, the specific protocols used, your rollback plan, or the tangible and intangible returns.
Well, as an engineer, I'd want to validate the design by showing off the protocols like BGP and VXLAN.
But the CIO doesn't care about BGP. They care about the business impact. You have to focus on the tangible and intangible returns, the ROI.
Right. Protocols and rollbacks matter to the technical team, but they aren't the primary focus for the customer pitch.
Show them the money. And a big part of that ROI comes down to smart licensing, which leads to our final question. Which statement is true about central licensing for gateways? Do we have foundation, advanced, and foundation base? Does SD-WAN need security licensing? Do WLAN gateway licenses provide normal SD branch features? Or does SD branch provide WLAN gateway features?
Those middle two are basically a riddle.
They really are. Yeah. I'd almost guess the WLAN license covers SD branch.
It's the other way around, actually. The SD branch license provides the WLAN features. Think of SD branch as a premium multi-tool, and buying it naturally includes the screwdriver, which is the WLAN gateway capability. The other options are just distractors. That's all the key points we shared for the HPE 7-A11 exam today. Thanks for watching. If you found this helpful, subscribe and leave us a comment.